Hello, so we continue with weight, mass, density, volume questions. Okay, so we're going to solve the second question as well as the third question for a series of videos on a number of questions that we're going to do, which I'm referring to as miscellaneous questions on mass, weight, density, and volume. So you expect to face a lot of different questions, but testing different concepts. So in this series, you'll be able to know which concepts are always important for you to highlight even as you study. All right. So you'll be able to know which things you have to know about these topics and which things you should ignore a bit. All right. So these questions, I collect them from examination papers. So make sure you stay glued as they are going to really help you as you prepare for your examinations. Right, so without wasting so much of our time, we are quickly going to jump into seeing how we can provide the best solutions to these simple problems that we have on the board. All right, so question 2 reads, a room measures 4.0 meter by 3.0 meter by 2 meters. The density of air in the room is 1.3 kg. Okay, so we're supposed to have 1 kg here. Right, 1 kg per cubic meter. What is the mass of the room? Okay, so the first thing that you're going to consider is the units first, before you even figure out which measurements are you dealing with. So if you look at meter, these are okay. Then this is also in kg meter cubic. All right, so this is also fine. All right, so now they're asking us to find the mass. Now let's see. So I'm saying question 2 data, what do we have? We have mass given. No. Do we have density given? Yes. And density, I always say the symbol is rho. Okay, kg cubic meter, like that. Then do we have volume given? No. But we can calculate volume since we know that volume is LBH. Right. So the room, you know, understand, say a room would look like this. Okay. So the volume therefore is just going to be the product of these. So which is 4.0 times 3 times that. So this is 12 times 2, that's 24. Right, so the volume, understand, so it's 24 meter cubic because you are multiplying 3 meters. So 1, 2, 3. That's the 3 that you can see on top there. Then the formula for density, you know that it's rho is equal to m over v, which is mass over volume. And this is nothing but just get the mass. Right, so what are you trying to find? We're trying to find the mass. So here just substitute now. So we have 1.3 is kg meter cubic is equal to meter over volume. We know it's 24 cubic meter. You understand that from here now you can cross and multiply. And the meter will multiply with the 1 here, whereby this will multiply with that. So what are we going to get? Meter is equal to 1.3 kg meter squared times the 24 meter cubic. Right. So you'll realize that you punch this in your calculator. So on your calc, as you punch this one, make sure you have a proper calculator, by the way. Make sure you have a proper functional calculator. So if you punch this, you're going to get 24. Okay. This is crazy, huh? 1.3. Don't know. Okay, so when you punch, this is what you're going to get, and it's definitely going to give you the mass. Okay. So my calculator as well sometimes misbehaves. Okay, here we are. So we're getting a 31.2 kg. So this is not in grams. You understand that you're dealing with the kg. Okay, so our units are going to be in kg since the density given was in kg per MB. So do not put grams here. Okay, so this is going to be the correct answer. Like that. Okay. Now, question 3 says 3 objects are cut from the same sheet. That is key, right? So remember the topic that we're dealing with. So the 3 objects are cut from the same sheet of steel. So the keyword here is the same sheets. Okay, so shape, same. They have different shapes, but so they are different shapes. Okay, they are different shapes, but they all have the same mass. All right, so we have a disc here, which is just as a circle, in a square, and the L shape. So which object has the greatest density? Which shape are we going to consider to have the greatest density since we have the same mass here? Anyone? Okay, but why do you think so? Okay, so without wasting so much of our time, you should realize to say, whenever we're given shapes like these and they're saying they are of the same material, so remember, density is a property of a material and it never changes. It's not like mass, it's a property. So you should understand to say density is the amount of mass per unit volume of the substance. So say this one, if it is same material but of different sizes, of course. So this can be 1 over, as this is the mass, of course, 101. This is the double this one, so this is the x, then this is 2 times. Okay, so this is going to be 202 by mass. So if the volume of this one, say the volume of this one, if it's 4, meaning the volume of this one is 8. Okay, so you understand, say you are going to find the same density. So these are objects cut from the same material. So even here, since they're cut from the same material, here you cannot say disk has greater density than this one, or this one has this. The only thing that you can compare about different objects is the center of mass, the location of the center of mass. Of course, the center of mass can be here in a circle and also here, but you discover this object, since it's cut, okay, so you realize that the center of mass can draw a line, so it can be somewhere here. Okay, so center of mass is what can change, but then if you realize when it comes to density, it's also going to be the same. So they have the same density since they were cut from the same sheet of what? Steel. Sheet of steel. Right, so this is how you tackle this question. So let's just create more space so that we put up another question that we are going to discuss together. Okay. Okay, so let's look at now question 4. And it reads that a body of mass 10 kg falling freely, so that's a key concept. Its mass is this one and it's falling freely in the gravitational field strength close to the moon surface and has an acceleration of 1.6 miles per square second. This is the acceleration. What is the gravitational field strength on the moon? Okay. So how do you calculate the gravitational field strength? It's very simple. I'm going to say solutions here. Okay, and we say Q4. Okay. So you realize that you're given the mass, okay, 10 kg, and the acceleration, so the gravity of okay, understand that finding the weight, so 1.6 miles per square second. But then you realize that weight is equal to mass times gravity, mg. W is equal to mg. So this is the formula that we're going to use. So firstly, with that information, you will realize to say we can find the okay, the weight. So with this information, understand to say we have this and we have this, so we can find the weight from there. So it's 10 times 1.6, and you are going to get the weight of 16 newtons. Okay, so that's going to be 16 newtons as a weight. Right. Now, this is the mass that we have. So the gravitational field strength now is going to be weight over mass, which is now going to be this weight over the mass is 10 kg. And this one, when you divide, you get 1.6 Newton per kg. Okay, it's Newton per kg because we are dividing the weight over the mass. So this is now what you're going to arrive at. Okay, so firstly you find the weight, then going back to the same formula. So the acceleration itself okay. So the formula, which is very suitable here for it to not to get confused, is to say force is in Newton. So the force can also be the pulling force is going to be force is equals to ma. So after I find this, then you can find the mass using this formula here. So this one is the same as this. By the way, these formulas are the same. Just depends with what you are dealing with. So first you can find the force, which is the same as the weight. Okay, after finding that, then you can find the gravity by making G the subject formula until you arrive at this. Okay. So let's look at how we can provide the solution to question number 5. So number 5 says the mass of a paper clip. The mass of a paper clip is the mass of a paper clip is 0.50 grams, and the density of the material is 80 grams per cubic meter, right? Then the total volume of the number of clips is 20 cubic centimeter. So we are supposed to have centimeter like that. How many paper clips are there? So I'm trying to find the number of paper clips given their total volume, and of course given their mass and the density of the material. Okay, so which formula are we supposed to use? We understand that density is equal to mass over volume. This one we all know. Okay. Now, to get the total volume, we're going to be able to find the volume of each. Okay. So total volume. So we say volume V of each clip. This is a paper clip. is equal to total volume over density. Okay? Since I've been given the density. That's all. Okay, so volume of each clip is equal to mass of, okay, volume is given, right? It's equal to mass of each clip. Okay, so you make a sample for me. So mass of one clip over density now. Density of a paper clip. And this is going to be, excuse me, so the mass, of course, is going to be 0.5 grams over the density of each clip, which is 8.0 gram per cubic centimeter. Okay? Let's see what we can get there after punching on the calc. Okay, so it gives us something like 0.0625. The grams are going to cancel. Then we're going to have centimeter cubic. Okay, so this is now the volume of each paper clip. You understand? Say in the question we've been given the mass of each paper clip, and of course the density of the material that it was made of. Right now, trying to find the number of, number of clips. Okay, so we now say number of paper clips is equal to total volume over volume of each clip. So the total volume we've been given to say 20 cubic centimeter over volume of each clip, that is 0.0625 cubic centimeter. And this is the ratio, so the centimeters are going to cancel to get the exact number. So that's 20, and you get something like 320. So this is going to give us the total number of the clips that we had. So just follow the question the way it is. We've been given mass and the density. So from this, we're able to calculate the volume of each paper clip. Just playing around with this formula. So you make it here, you just make it V the subject. So it's going to be here, it's going to be V equals to M over rho, which is this here. Then substitute the information given, you get that. Then that's how you're going to get the answer. So make sure you practice as many times as possible. If as well you feel you can try this question, you can just pause the video, then solve the question, then play the video to see if you've done the correct thing. Otherwise, stay glued to our channel and don't forget to like, share and comment on each and every video that you comment. Thank you.